Hi everyone. This video will be an instruction video about how this effect is most likely working at my best understanding. Here's my preferred coil, which has got the dual coil, dual windings, and here is an identical core that's wound with the same wire in a standard way that a toroid is wound. So it's just a single coil on it. Okay. And what I've done is I've got this coil to the identical DC resistance as that one. People were taking all kinds of shots, at this. It's about DC resistance. No, it's the core. The other one's an air core. This, that, and all the rest of it's the magnet. It's all kinds of things. So I think it's pretty simple and doesn't need to be complicated. The effect is really about inductance, and that's the bottom line. Right now I have my quality meter here hooked up to this coil here to measure its DC resistance, and if we have a look, that's what we're measuring, DC resistance on there. So we're exactly at 7 ohms. That meter shows a little bit more, but it's actually a little less. It's a little under 7 ohms because of the resistance in my probes. I already checked that before. Okay, now let's just hook up this coil here for comparison here, and that's all what we're going to do. We're going to compare the two coils, and if I hook up that coil, okay, I've got identical reading. We've got 7 ohms as well on that one. So now the two coils are perfectly matched, okay, as far as core, wire, DC resistance. Okay, now there is one thing though, they're not the same. What's different is inductance. So here is my inductance meter. I'll connect this coil here, okay, and we'll check the inductance, and that's what we're getting. Okay, so about 664 millihenries on that one, which is using the same amount of wire, same core, same everything, okay? And this one here, that's what we're getting. So close to 1.2 henries. So there's a big difference, okay? This one is close to double the inductance of this one, and yet they both have the same DC resistance. So I'll tell you, the effect works better with this toroid than that one because of the very fact that this one has a higher inductance. So when you apply a magnet, okay, first of all, yes, the effect works with a magnet to be able to send back energy or to be able to get this extra energy. You have to use a magnet, okay? But what happens is when you put a magnet on, because it's a ferrite, the inductance drops. When the inductance drops, the characteristics of the coil changes, okay? And you need a good amount of powerful magnet on here to be able to get that energy. But when your inductance drops, that means that the energy you're putting in there cannot create a very strong magnetic field, because to have a strong magnetic field you need a high enough inductance, okay? So why this coil fails compared to this coil here, okay, is this one has close to double the inductance. So when you put a magnet on this one, it's already got twice the inductance of this one, okay? I don't even need to hook this one up to pulse it to show you that it's not going to work very well, because as soon as I put a magnet on this one, it's going to perform half of what this is. And like I say, the more magnet that you put on it, okay, the better the return energy is, but the more it drops your inductance. And if you don't have enough inductance to be able to push a magnetic field to push against that magnet, what you're going to get back when that switch shuts off and the electromagnetic field switches off is you're not going to get that kick. Okay, you need remaining amount of inductance. There has to be a balance between how much magnet you put on there and how much residual inductance you have left, so that when you do pulse the coil, that inductance will create a good enough, a strong enough field, okay, to push that permanent magnet field out, okay, and then when it shuts off, that flux comes rushing back in, and there's where you pick up the energy. Okay, so again, there's no point in me testing this coil. The whole thing is that simple. Okay, this one performs half as good as that one. I can get this one to just barely go to 0. Okay, when I get the right balance of magnet on it and, you know, left over enough inductance for it to go back. So the secret is, okay, it is that simple, is you want the highest inductance as possible. So if you want to, you know, replicate this effect, wind it so that you have 2, 3, 4, 5, 10 Henrys. Go out to town on this one, you know. That's where you're going to get your benefit. Okay, so if you can actually get a toroid up to 10 Henrys, okay, and you put a magnet on there, okay, and it drops by half, you still have 5 Henrys, okay, of a magnetic field to push against that. And I tell you, you're going to get a better result that way, and it'll pulse at a lower frequency. Because what happens is, when I put a magnet here, okay, the stronger the magnet is, the less, again, the inductance is, and the higher the frequency will be that I will need to actually pulse that, okay, or to get that ideal point where it's creating a lot of energy that's returning, okay, for it, the energy going in comes to nil, right? So that's what the whole effect is about. I don't know if that makes any sense to you, but anyone that has been following this, you know, is probably going to understand what I'm trying to say here. Now, the other interesting thing is I'm capable of creating a circuit that's pulsing the MOSFET, okay, self-pulsing it. And now it's very simple. It's just an inductor, okay, again, a small coil that's between the source and the gate of the MOSFET. And I'll be giving those details away, okay? And it's taken me a lot of time to figure it all out, but you know, you can only do it when you experiment with it. And what's happening is you can't get this effect, okay, using a transistor, because a transistor doesn't work. There's a difference between the MOSFET and the transistor. In the MOSFET, there's capacitance built into the MOSFET, and it's that capacitance that's going to start resonating with that coil there. Okay, and then when this starts resonating, then the whole switch and everything works in combination. But there's a certain amount of inductance here, there's a certain amount of inductance there, and at a certain frequency, the combination will work. And it's you know, a little bit more difficult than what I'm just saying, but I've done a lot of these tests, and I've got a lot of the data down, and somebody at this time is actually you know, doing a study of it. And who knows, we'll maybe even write a program that you could just put in your coil inductance once your magnet is applied, and it will tell you from whatever MOSFET you're using to utilize a certain amount of inductance here of a coil to get this thing to self-resonate. And that's it, you know. So this does work. It is, you know, somewhat efficient here. I can get it more efficient. Like I say, I got to bring up the inductance level, okay, and I should use a wire that has less DC resistance. And I think that will be the way to go for the next build. So that's about all I can share in this video here, and thanks for watching. And if anybody is still wanting to see a demonstration between the two differences of these things, hey, I'm ready to do the video. But I tell you, take my word for it, this performs half as good as that, and it's basically just because this one has more inductance. So that's where you got to go. All right, so thanks for your time and interest, and we'll talk to you later.